This episode is sponsored by Linode. Do you need a Linux server for your latest creation? Then check them out. They provide native SSD storage, 200 gigabit per second network connections, Intel E5 processors, and top-of-the-line hardware to run your servers on. It deploys Linux in seconds from a Linode cloud, and you can choose your Linux distribution and node location right from the manager. They have locations in Asia, North America, and Europe, and a sweet set of tools to make it easy to manage it. If the web interface isn't your thing, they also have an API and a command line. They also provide two-factor authentication, IPv6, DNS manager, plumbing, scaling, and everything else you would want. So get the most out of your Linux node by checking them out at linode.com or devchat.tv/linode. Hello and welcome to episode 90 of React Native Radio. I'm your host, Nader Dabbit. Today on our panel, we have Lee Johnson.
What's up?
And our special guest today is Zubair Ahmed. Welcome to the show, Zubair.
Thank you, Nader. I appreciate it.
Yeah, we're excited to have you on. This is a little bit out of scope for our regular show. We're going to be talking about blockchain and Ethereum development today. And we're going to also be trying to fit in React. I know you've written a really well thought out and lengthy blog post about React development with Ethereum. But really, I think the underlying thing that the discussion is really going to be about is Ethereum. But I'm really looking forward to see how the two interact and kind of your thoughts on the whole technology itself, the blockchain technology, and specifically Ethereum, and kind of why you're focusing on Ethereum. So before we get into anything too technical, can you kind of give us a quick intro of who you are, how you got into programming, and what led you to Ethereum and React development?
Yeah, that would be a pleasure. So, hello everyone. My name is Zubair Ahmed. I like to say I'm a full-stack Ethereum developer, or full stack Ethereum engineer, however you like to say it, because I do the architecting part as well. I stumbled onto blockchain technologies entirely by accident. So I'm trained actually as a mechanical engineer. I went to school for mechanical engineering, and I studied robotics for my master's, and then I worked in industry for a little bit. As I was working, I concluded that this is not the right industry for me, so I wanted to pivot. And after some reflection, I realized that software engineering is where I could contribute most to humanity, is a way of saying it, I guess. This is a way I can serve humanity. So that's how I jumped onto the software engineering train. And as I was teaching myself, I ran across a friend who couldn't stop talking about blockchain. He was just like, blockchain this, blockchain that, it's the future, it's the future. And he was so genuine about it. I was like, whoa, dude, I guess I should take a look at this. And then that was the genesis. And I got into the Ethereum blockchain specifically because it allows developers to write programs, write smart contracts that can execute logic to do XYZ things. Yep, that would be a short version of the story.
Very cool, very cool. So what have you been able to kind of transfer from your other engineering into software engineering? Like what, I guess, logic or principles have you kind of been able to kind of use in both spaces, just out of curiosity?
Yeah, no, definitely. That's a great question. So a lot transfers over pretty one-to-one, actually. I was a little bit surprised by that. Very specifically, engineering thinking translates very one-to-one. Like, how does one approach a problem? How does one resolve it with the tool set they have at hand? These questions, I didn't have to reinvent. So when I face a bug, I can be like, oh, okay, I guess I should narrow it, and then I should try this approach, try that approach. Oh, this is happening. Oh, why is that happening? Like, what is really going on? Like, it was very easy for me to dig in and just make resolutions. So problem-solving maps, and then designing maps even more properly. I don't know how else to better say it. So like in engineering, we take a step back and we make blueprints of systems. And that's what we have to do in software engineering as well. Before we write a single line of code, I always tell people it's best to put in as much time into designing the architecture of the software as possible, so that when execution happens, there's no confusion. There's no need to make decisions while the code is being written, because all the decisions were made before. And that's very efficient. It gets the software out faster. Of course, agile principles have to be considered, and we have to be open to our root design changing to some degree so that we can morph to the market and customer needs. However, like just to take a step back and talk about like all this way that I'm discussing, all of this stuff came from my previous engineering and was not new to me. And I just had to learn some languages and specifically digging into the Ethereum blockchain to see what's next for me.
So I guess the question that I have is, what is Ethereum development specifically as it relates to just general blockchain technology? I guess for me, I have almost zero knowledge of actual development. I kind of understand the concepts behind blockchain and how they're applied to cryptocurrency. But I guess what I'm really having trouble tying together is the link between Ethereum, blockchain, and cryptocurrency and how they kind of relate.
Yeah, totally. Let me see if I can help.
I know that's a pretty large question.
And maybe just start with blockchain. What the heck is blockchain?
Yeah, yeah, that's a great little parcel of that question. So a blockchain is actually just a data structure. It's nothing more than that. It's essentially a linked list data structure where each node points to the previous node. That's it. That's essentially what a blockchain is. However, what makes a blockchain special is genius people figure out a way to inject cryptography into the structure that makes it immutable. So essentially, what people, it's easy to talk about it with the SHA-256 function. So essentially, when you put in some amount of data through a SHA-256 function, you get a hash. And this hash is a representation of the data that you put through the function. And you can put in any amount of data through this function you want. You can put the whole Library of Congress through this. You can just put just a space through this. You can put really any amount of data you want through it. However, the output is constant. It's just this string of hexadecimal characters. So what makes a blockchain special is, suppose say you have a block, right? And the block has some data on it. You put that data through this function or any other cryptographic function that you might want to use to innovate, because the space is ripe for innovation. And then you get a hash. And that hash is the block hash. The next block that comes in the blockchain points to this hash and has its own hash. And then the next one that comes points to this previous hash. So like this, you get a chain, and each block contains data. Now, here's where blockchain becomes immutable, right? So each block, its data is represented by this hash. So now if somebody goes and changes this data, the hash also changes. If the hash of a block changes, the previous block is no longer pointing to this block. So it can send a signal to the system that, hey, somebody tampered with this blockchain. So this is what makes a blockchain special. And abstractly, like at a fundamental level, this is what it is. It's just a special data structure, right? And then the Ethereum blockchain is built on top of this data structure. They figured out a way to see. So right now, remember I mentioned data. We can put data onto a blockchain, right? This data can be anything, like anything. We can just imagine anything that data could be and put it on the blockchain, right? There's of course limits currently that we're dealing with practically. However, for the sake of imagination, let's go there, right? Anything can be put on a block, anything. So what Vitalik Buterin did, his genius was saying, why don't we put programs on the blockchain? Like, why not write like code that can be executed on the blockchain? So this is the real innovation of Ethereum. We can make programs that execute on the blockchain. So these programs are in general called smart contracts, and they tend to be, at this current snapshot in time, simple programs that can capture business logic. And let's see, the third part of the question was, how does cryptocurrencies tie into this? So Ethereum and blockchain in general very much promotes decentralization. So it's a way of democratizing technology and computation. So how does one incentivize people to join this democratic network, right? And the current way in our system we incentivize people is with money. So when one adds a node to the Ethereum computational machine, one gets the opportunity to earn some money. And that's what is generally referred to as mining. And how that works in the Ethereum space is there's two sections, I like to say, of money going around. One, money to pay the miner for processing one's transactions or like executing code on some smart contract. And that unit of money is called gas. Gas essentially is not really connected to any money. We have some properties on the transaction, one called a gas limit and another called a gas price. I'd be very happy to dig into that to say how the cost of a transaction is derived, and that cost goes to the miner. So as me and you, if you want to join in, this is how we can do it. And cryptocurrencies, Ethereum has its basic currency, Ether. That's what, and many denominations of Ether, I should say as well, that operates the system. So people can transact value through Ether. And since smart contracts allow us to write programs, we can make our own tokens. And then this special property of being able to make a token on a smart contract has generated quite a few billion dollars in the last year or so. So yeah, does that take a good first stab at the question?
That was probably the most succinct answer for what is Ethereum, and overall it was a very good answer. Yes, but it really helped me understand like what makes Ethereum special. So basically, you're saying that as opposed to just having like a hash on the blockchain, Ethereum allows you to execute programs.
Mm-hmm. Yeah, that's definitely the innovation of Ethereum.
That's interesting. So kind of like what would be a use case for something like that? Like in my head, what I'm thinking right now is this program only gets executed once, but is it basically the Ethereum program would basically be something for people to use over and over, or would it be just something that's executed once?
So those are great questions. So just to get a little bit more detailed, so one first writes a smart contract. That smart contract these days, the most popular language to write it on is Solidity. So one writes a Solidity smart contract, and that smart contract gets compiled down by however means. There's a few means that we can use, but let's say we're using the SulkC NPM module to compile that down to bytecode. Bytecode is what's read by the Ethereum virtual machine to execute the codes that you wrote. But let me take another step back because I'm getting too detailed. So one writes a smart contract in Solidity, and then one deploys an instance of this contract to a Ethereum blockchain. I say a Ethereum blockchain because there are currently a few of them. There's the mainnet. There's only one canonical mainnet where people use real money to deploy real smart contracts to build real companies. And on top of that, besides that, there are test networks. And I'm very grateful there are test networks because otherwise Ethereum development would be a little costly. There are test networks where we can deploy dummy contracts. Well, not dummy, they very much mimic what's going to happen in the mainnet. And the main difference is it doesn't use real money. So one doesn't have to use real Ether to deploy to these testnets. There's Robson testnet, Kovan testnet, Rinkeby testnet, and these are the testnets that exist right now, and they use slightly different properties. But you can essentially pick one to test out the smart contract. So once an instance of a smart contract is deployed to one of these testnets, you can interact with it. But how does one interact with something on the blockchain? This is where I personally recommend React through the Web3.js interface. So Web3 is this, I guess they call it Web3 because it's Web 3.0. So that's probably where the name came from. But we can use Web3.js now to link up to this contract instance that we deployed to the blockchain. And now once we have linked up to this contract instance, we can execute whatever function we wrote into the smart contract. And now there are generally two kinds of interacting with the smart contract. One is just reading data. So you can just read data. And this is free. So if a smart contract, say, contains Siddhartha by Hermann Hesse, right, the book, it probably can't do that right now because that requires a lot of gas to write that many strings. I actually tried to put up a poem on the blockchain and it required too much gas, so I couldn't do it. But let's just assume for the sake of a conversation that you have Siddhartha on the blockchain. You can just read it and you don't have to pay any price for it. So that's that. And now suppose say you're trying to add Siddhartha 2. I know it doesn't exist, but for the sake of conversation. So that the two came out, right? And you want to add that to your smart contract. And you've baked a function into the smart contract that says add novel, right? And now you can just like give it the argument of a string, which is the whole novel. And you can add that to the blockchain. This kind of transaction is mutating the state of the smart contract. And this requires money. This requires money that will get paid in the form of gas to execute this. And people have broken down like gas costs, so people can go and be granular about and know beforehand how much money it might cost them to mutate the state of the Ethereum blockchain. So this transaction, when it's sent to your smart contract, gets mined by one of the miners that we talked about. It could be me, you. The miner takes a lot of transactions and pulls it into a block, and then mines that block and then broadcasts that out to the whole network, which then engages in the consensus mechanism, which is moving to proof of stake right now for Ethereum, and then verifies that, yes, this is the canonical block. So with that transaction, you actually mutated the state of this global machine. You change the state of your smart contract, but that smart contract to represent that change has to go, it has to be recorded, right? So the smart contract can do many things. It doesn't have to be used just once. You can read data from it infinitely. You can mutate it infinitely. It boils down to how the smart contract was designed and what purpose it serves.
That is a lot of information, I guess, but it's really interesting. No, it's actually you're very knowledgeable about this stuff, and you're able to kind of talk about it in a way that's a lot more consumable to me, at least, than some of the other stuff I've heard. So this is my first time hearing about this concept of gas, to be completely honest. So you mentioned like briefly that it's kind of a way to transact or pay for things when you're dealing with Ethereum. Can you kind of go into a little more depth about that? Like, how is this only for Ethereum developers as a way of currency or a form of currency, or is this and how does this actually relate to Ethereum as a cryptocurrency, or does it?
Yeah, totally. So gas, in its essence, is paying for computational resources. That's pretty much it. The analogy of a car is appropriate because, gas and car needs gas. To run your car, you need to use gas. And you're paying for the car's, say, computation, which is the engine revving, with the gasoline that you put into it. In essence, gas is just like that. So suppose you have a smart contract and it needs to run 3 lines of code, right? Somebody has to run these 3 lines of code. Like somebody's computer has to compute these 3 lines of code. And to incentivize that person to compute these 3 lines of code, the concept of gas exists. So how much gas lines of code execute is how much you would pay. This is where I said like there's the gas limit and the gas price. So maybe this is a good point to talk about that. So when you send a transaction that will mutate the state of the Ethereum blockchain, you put in these 2 properties, gas price and gas limit. Gas limit says, hey, computer, this is how much gas I'm willing to pay maximum to process my transaction. And let's just say it's 1 million. You're willing to pay 1 million units of gas, right? To pay for the computational cost for that transaction. And now you're like, okay, all right, here's the units of gas. Now, how much price am I willing to pay per unit of gas? How much price? This is another way to incentivize miners to pick up transactions. And this is where gas price comes in. So you set a gas price. It could be really low, it could be really high. And the gas price, let's say for the sake of conversation, it's 1 ether, right? Like you set the gas price to be 1 ether. And your transaction, you say maximum I'll pay 1 million ether. That's a very big number, but we're just we're just talking about it for the sake of conversation, right? So you're willing to pay maximum 1 million ether for this very important transaction, right? And it ends up taking, let's just say for the sake of conversation, 100 ether, right? 100. It actually consumed 100 units of gas, right? So it consumed 100 units of gas, and now it's going to look at the gas price and be like, oh, how much were you willing to pay per unit? Oh, you're willing to pay 1 unit per 100 units of gas, 1 ether per 100 units of gas consumed? Okay, so that's 100 ether. And they charge you like that. But now suppose say you were like, I'm willing to pay 0.1 ether. And the same transaction, and it cost 100 units of gas. Now, because you're like, okay, I'm willing to pay 0.1 ether, now the transaction is going to cost you 10 ether. So that's how ether relates to gas. And Ether is entirely separate, like this example should convey. And just to recap really quickly, gas is just paying for using computational resources on a decentralized network, and it's specific to the Ethereum network. Other networks are free to experiment and architect in any way they please.
Cool. So how the obviously the gas price, the more you put in there, the more likely someone's going to agree to to work it for you, right?
Mm-hmm.
So how, on the other side of that, how do you, as a miner, get involved in that process?
Yeah, so a miner can pick transactions that they choose to mine. So a miner has quite a bit of power. They get to see oh, okay, all right, this person is willing to pay this much gas, this person's this much ether per gas, ether per gas unit. So they can look at the gas price, and usually what I've heard miners do is they sort it from the highest gas price to lowest gas price, and then they chop off a certain amount from the bottom, and then they include the highest gas prices on the transaction. So you're completely right when you say high gas prices will incentivize the miner to take it up quickly. So if you do actually set the gas price to be really high, the transaction gets mined faster. So because people are on it, they just want to earn that reward for themselves. And if you have very low gas price, the transaction could take a few minutes. So in essence, if a transaction is really important, it's advised to put, a higher gas price. And if it's not as important, then the user can wait a little bit. You can put a low gas price. So it depends on the circumstances. Mm-hmm.
I'll just say this is just for explanation. I mean, this is widely distributed, so there are lots and lots of miners. Basically, they set their computer up right to run and acknowledge certain contracts, and I assume automatically run them if they fall within parameters and things like that. So it's distributed through just, I guess, thousands of different people's computers.
Exactly. Yeah, and that's where the power in this comes, because there's no central authority to guide the state of the blockchain, specifically the Ethereum blockchain. Since we're talking about that, any blockchain actually, the decentralization component is very critical. Not any actually. Let me take that back. Blockchain is a data structure at the end of the day, and people can use it in any way they please. So the Ethereum blockchain's design specifically makes it decentralized, and no party can really go in there and pollute the data. A record is kept. Everything's public. People can just go to Etherscan and just look at what's on the Ethereum blockchain. It's not hidden. So yeah, it's definitely decentralized, and that's where the democratization power comes in. Like I was mentioning, it's definitely still a promise because we don't know how it's going to play out. But the fundamentals of it are so strong and so profound. I have faith in it, and I want to just ride it out. See, I feel very lucky that I've been able to jump on it so early. So let's see how it goes.
So specifically with the cryptology involved, so it's encrypted to the hash, and they're linked, so you can't, they're immutable and everything. If I were a miner choosing to devote, my power and resources to solving this, how is that hash and encryption portion, I guess, protected in that part?
Okay, so let me see how I could best answer that. So essentially, right now we have to bring in the concept of public key and private key. Mm-hmm. So a public key is the key that you own, that everybody can see. It's public. And the private key is something that you hide from the world, and it's yours. When you're sending a transaction, the transaction is signed with your private key. And this is where the cryptography enters. It's signed with your private key, and then you get a transaction hash, and then you send it over to whoever you sent it to, right? And then that person, looking at that transaction hash, can use some cryptography to verify that, yes, this transaction indeed did come from you. And this is where the peer-to-peer of blockchain comes in. This is actually the essence that I describe right now is how Bitcoin is powered. and why Bitcoin is so successful. So see, the end person doesn't have to know me at all. They just have to somehow verify that I sent the transaction and that that transaction has what I promised I would send. And that's it. So it creates this space where parties don't have to know each other or trust each other to transact value. So going back to the miner, that's how so for Ethereum, you can set up a Geth node, you can set up a parity node, and those nodes are the ones that help you process transactions. And the guts of that, I am not familiar with. I know that the consensus algorithm, proof of work, if we're just going to talk about proof of work, requires the miner to solve a complex math puzzle, a cryptographic math puzzle. And this puzzle essentially can only be solved by brute force. And what that means is like, try this, try the next one, try the next one, try the next one, try the next one. And like this, you keep on trying solutions until you find the solution. Hence the inefficiency. It's not very efficient. So the miner essentially has to engage in whatever consensus algorithm the network relies on. And then it's a bit of luck, really. If you have the fastest computer, you could have a better chance of mining a proof of work network. And proof of stake requires you to put some money up at stake. And then if you verify a block and then you verified it incorrectly, you lose your money. So there's more incentive for the miner to ensure that they did properly verify the block. So the consensus algorithm is really where the miners are playing with each other. And each transaction that goes to the Ethereum blockchain has to be processed by every single node. So every single node is in on this game, so to speak, race in a sense, to verify and get the canonical block on the Ethereum blockchain. Does that help answer your question a little?
Very cool. Yeah. Thank you.
Mm-hmm.
Yeah, absolutely. My pleasure.
So I guess I have a couple of questions around actual use cases. So if someone is listening right now, like how would they, if they got into this Ethereum development, could they apply this knowledge to solve certain problems that are kind of in need right now? Like what would you use Ethereum development or Ethereum smart contracts to accomplish? I know I've heard of the most notoriety I've heard from any Ethereum project lately has been that CryptoKitties project, unless I'm missing something. That seems to have gotten a lot of press. But I'm kind of curious, like how that even works with Ethereum and what are some other use cases that people could kind of use to do stuff with?
Yeah, so I personally think with Ethereum, the most interesting interaction of Ethereum with the real world is in economics. What Ethereum and several other blockchains allows us to do is create a token, right? A token, for the sake of legality, is not a real currency, right? But however, it contains value, and with this value, people can really innovate. So, like, what are people going to do now that they have this capability to create tokens that represent real value? They can create niche economies. They can disrupt current economies. Like the financial sector right now is in quite a bit of disruption because of all of this blockchain technologies and applications built on top of it. I'm currently working with a friend on an insurance platform. So you can just like simplify the insurance process using the Ethereum blockchain. Like there's no more need for like signing complex contracts, agreeing to pay middlemen this much, this other middleman this much, agree to pay the banks this much. All of that can be taken out and just put into a smart contract. So the cool part about a smart contract is the logic is right there and people can just see it. And it's not all this fine print and all this stuff that we usually have to dig in if we really want to understand what we are agreeing to. Another cool thing about a smart contract is it's self-executing. By that, what I mean is if certain conditions are met, it can just disperse the money. Like in the claims, in the insurance industry, you can say like you put in a claim, the claim goes into the smart contract, the provider is like, okay, all right, I agree. and then they click a button, and then the smart contract disperses the money wherever it needs to go. It drastically leans out this process of how money, how tokens, I should say, value. Maybe that's a good abstract way of looking at this. It creates new channels into how value can flow, and this opens up a very wide field for innovation, especially in places where financial institutions might be taking advantage of people, or institutions where your data, you don't know what's happening with your data. Like, you don't control your data. The institution does, and they can sell it here, sell it there. With the blockchain, we can give data back to the users. We can tell them that, hey, here's the smart contract that contains all your information. And then other applications can interact with this to get your data. And that's really powerful to me. I was reading an article in New York Times talking about how we can just get control back, really, of our digital lives using blockchain. This is a promise. We have to execute on the promise. So definitely not there yet. But wouldn't that be cool? Like, for example, like, let's take Facebook, right? Facebook owns so much of our data. They just know so much about the 2 billion users that Facebook has, right? And suppose, say, now a new competitor comes up, right? A competitor to Facebook or something. It's very, very difficult for us to switch to it because there's so much inertia Facebook already has. It has all our friends, it has all our photos, it has all our likes and all our history, etc., etc. So switching to this new competitor, which might be on all levels better than Facebook, is very difficult. But now imagine a scenario where Facebook doesn't own your data, right? It doesn't. It just uses your data to give you a service, right? That's cool. So now you own the data, and now a new competitor comes out that simply offers a better service than Facebook. You can just plug straight into it. All the data belongs to you. You don't have to beg Facebook or something to give you all the data so that you can transfer over to this new network. The new network will ideally have an API to just interact with your data and can use that to build a service to give to you. So these are some examples that came to the top of my mind. In essence, it takes a radical new approach to value creation and really strongly empowers the individual, which I think is good. Like, if we can deliver on these promises, I think the world will be a better place.
Yeah, and it's really, I guess, up to the consumers really at that point to demand this, you know.
Yes.
Yeah. And in the case of data, if you could put your personal data in a blockchain and obviously update it through, having miners work it and add your changes whenever you need to. But if a company were to access your data, if there were the same type of Ethereum cost or gas cost for accessing that data on you that you set, like, I'm willing to share my data for this. And then the whole structure of advertising and data, and it changes, right? You actually directly benefit from someone using your data instead of the other way around. They benefit from using your data.
Yeah, it's a radical reversal in who holds the power, and it's really up to time to show us what this will manifest into. But at this moment, pretty exciting proposition, pretty exciting potential.
It's exciting and it's cutting edge, and it feels like it's ahead of its time. Like, I'm wondering how viable a platform kind of becoming, anything like on the scale of a Facebook that's kind of built on something like this is, like, in the near future. Do you see this happening, like, in the next 6-12 months, like anything significant? Or do you feel like something like what you're talking about as far as like large scale adoption? I know we're seeing quite a bit of companies kind of taking advantage of this type of technology, but I guess what I'm thinking is, like, when is this going to be just a normal thing, as opposed to kind of like a new and like a new thing, I guess you would say. So when is this going to become like more the norm, I guess, like, in your opinion?
Yeah, so my opinion on that is it's not very close to mass scale adoption quite yet. I was on a panel speaking at Stellar, which is an amazing blockchain company, by the way. Definitely recommend looking at them. I was on a panel there, and a couple of my fellow panelists had this one specific problem that all blockchains face, and it's called onboarding. We have to get people on board, and it's not trivial. We have to give people enough of a reason to change the way they currently lead their lives. And that is not an easy problem. Like I remember reading somewhere when the telephone came out, people were, yeah, companies were like, oh, hey, here's a telephone. You can talk to your neighbor straight through this wire. And people were like, I can just walk there. So it took a long time for like people to adopt the telephone. And I think something like that is going to play out here as well. So in the next 6 to 12 months, I can see already there's brilliant ideas in the space. Brilliant. I'm really excited to see like what all the smart minds in humanity do with this technology. But in the next 6 to 12 months, maybe too soon. My gut tells me it'll take a little bit longer than that. Since cycles are so fast these days, maybe like 5 years, maybe 10 years, but not quite yet would be my take. And also like Google and Facebook and Amazon and Apple, all these companies, they have so much wealth. I think they're just eyeing this technology, and if they want to jump on, they can also create new disruptions. Just with the sheer economic force that they have under their belt, they can do that. So definitely unknowable. I'm not sure when the next big thing will come out in this. It might very well have been already brewing, because Amazon came out in 1995. That's when the internet got publicized. So it's been like brewing for a little while, and only like in the 2000s did it like really explode, and it's thriving right now. Like it's such a beautifully designed and run company. So yeah, that's my take. I don't think it'll be soon.
Like I know that you mentioned Stellar, which is super cool considering that I've kind of been following that project. I had no idea that you were kind of also interested in it, and actually we're at a panel that's really cool. That's kind of a YC company, right? That they're like, as far as, isn't there someone on the board that's from Y Combinator?
I believe so. I'm not sure though.
So I guess all of the discussion so far kind of leads us to kind of how can our listeners use React to kind of build Ethereum applications, and also this kind of doesn't really go along with that 100%, but you mentioned how Ethereum, in your opinion, would be a good use case would be working in the financial sector or doing something with financial. And I know we mentioned Stellar, and I always associate Stellar with kind of like a banking coin or a transactional coin. I don't really know a ton about it, but from what I understand at least. And in my opinion, like whenever I think about this stuff, I feel like the first massive company that is going to use this technology is going to accomplish that by offering a really very efficient payment gateway. And I guess I'm kind of curious what your opinion is on that. And also next, how React goes along with all this, and also how React and Solidity kind of work with each other. I know that's like 2 or 3 big questions, so I'll let you just take one at a time.
Oh, that sounds wonderful. So, yes, financial applications is like the current buzz, really, because somebody has figured out a way to disrupt sending value over electronic signals. So naturally, that would be the first place to get disrupted. I'm more excited to what comes later and what can help us lead better lives. So that's where my interests go. So let's see, what were the questions? So I'll go ahead and dig a little bit into the React plus Ethereum thing. This is a great place to just like quick small plugin for the blog post I wrote on Medium, React plus Ethereum, minimal tool set required to engage a smart contract. It's actually reasonably easy to deploy a smart contract to an Ethereum blockchain and interface with it. So again, I'll mention a blockchain is a data structure, right? And smart contracts is some data that lives on this data structure that gets executed by the EVM to do really anything, transfer money, store poems, like whatever use case people want to engage in. So React, okay, so there's this blockchain, right? It's living somewhere, great. It has all this stuff that we want to do. It has all these smart contracts that can help my business, et cetera, right? How does one interact with it? Like, how does one like be like, oh, okay, execute this function. Okay, all right, execute this function. this is where React comes in. And React really any front end, like it can just be just standard vanilla HTML and CSS and JavaScript. I recommend React because React is very fun to work with and easy to work with and very easy to spin up applications on. For the blog post that I wrote, I just wanted to keep it extremely simple. The blog post is designed for absolute beginners. I just use create React app. That's fine. Just use that. Go ahead. And then that spins up a boilerplate project that we can adopt, right? And we can just go to app.js and start playing. And to start playing, we'll have to install Web3. So I use NPM Node Manager. People can use Yarn as well. Just install Web3. And then what you would do next is give Web3 a provider. A provider is actually, hold on, this is not necessary. I'm talking about the minimal tool set required. So to use the minimal tool set, all you would have to do is use this beautiful tool called Remix. Remix is an online IDE for developing Solidity smart contracts. You just go to remix.ethereum.org and you have this editor and you can write smart contracts in it. To write Solidity, it's a little bit of there's a little bit of an onboarding cost in the sense that you would have to read the documentation a little. It's not very complicated, but I strongly recommend reading the documentation through at least once so that there is a at least subconscious understanding of the tools that are available to solve problems that may arise as somebody's making simple or complex smart contracts. So one can just go to Remix, write a smart contract, and then Remix allows us to deploy the smart contract onto any testnet we choose, which is really lovely. So let's say we're going to deploy it to the Rinkeby testnet. It has an environment option where you can choose injected Web3. And when you click on the injected Web3, what that does is it checks essentially for a Web3 instance that got injected into the browser environment. And there's this great tool called MetaMask that does that. So you install MetaMask, and then once you sign up for an account, every website you go to, MetaMask injects an instance of Web3 to it. So when you're on the Remix website, it has a Web3 instance injected into it. So you just select injected Web3, and then you just create the contract. And Remix under the hood takes care of compiling Solidity down to bytecode. Excuse me. And then using the Web3 instance to deploy an instance of the smart contract on the chosen testnet, right? So now on the chosen testnet, the contract lives at a specific address, an address. So we need that address. React needs this address because React needs to know where's the smart contract living, right? It needs to know that. And it needs to know, okay, all right, I know that the smart contract now lives in this address, but how do I interact with it? Like what kind of interface does it have? And this is where the ABI, the application binary interface, comes in. This is another thing that Remix spits out. You can just copy that and plug it into your React front end. And then you're ready. Like, that's all you need. You just need to know where the contract is living, so the address of the contract, and you need to know the interface of the smart contract, which is the ABI. And then you plug it into React, and now React knows how to interact with the specific instance of the smart contract. And the specific instance of the smart contract, say it has a function called getName, right? Just getName, and getName returns a string with our names, right? You can just call that function from React. You'll just be like, okay, all right, here's the contract instance. All right, I'll just call this contract, and you get back our names, and that's it. It's actually very beautifully simple, in my opinion. I like these essences of things where, like, the essence is simple, and then you can build very complicated things on top of it. And that's how I definitely feel about React and blockchain. So just to reiterate really quickly, React is essentially just a GUI to like engage with specific smart contracts that gets wired up with that GUI. And to wire it up, we just need to know the address of the smart contract. We need to know the ABI of the smart contract. And since MetaMask has already injected a Web3 instance that into our React application that we can interact through, we don't need to really worry about installing Web3 or setting up Web3 or anything like that. So this is a very easy way to just jump on. There are a couple of caveats that I would love to just mention to our listeners. MetaMask currently uses version 0.20.4 for Web3. And this is the version that's before 1.0, and it uses callbacks to operate. and that can get a little messy. So it's as we know, callbacks can get really nested, and there's callback hell, people say. So it's not the ideal interface, I have to say. They noticed this, the authors of Web3, and now in Web 1.0, it's promise-based. So we can now use brand new ES7 syntax like async await to write more beautiful code, more easily understandable code on our React application. And to hook up, so there's a versioning conflict that comes up with this. So I just mentioned MetaMask uses 0.2, and then there's 1.0. How does this versions work? Because if 0.2 uses callbacks and 0.1 uses promises, like there's bound to be some conflict and some messy code. So the way we can do that is just install Web3 on our local project, and then give Web3 the provider for MetaMask. So MetaMask injects, the Web3 it injects has a provider, and that provider connects with the Infura servers. Infura is this infrastructure for Ethereum that exists for our use, so that we can easily interact with the Ethereum blockchain. So MetaMask uses that infrastructure. So we can just give that provider to our version 1 Web3 on our application, and then we can go ahead and just use async await and promises to engage with the smart contract. So I know that was a lot of information all at once, but just to communicate, that's actually it. It doesn't get more complicated than that. So just learn Solidity, learn how to wire up the Web3 instance with the address and the ABI, and good to go. I can create innovative companies now. So I feel good about the essence. I feel glad that it's not overly complicated.
Awesome. Yeah. And again, to plug the blog post, that's kind of how we connected. I was reading his blog post and I was just extremely impressed. So if you want to learn, it was really well done. If you want to learn more about, what he's talking about, definitely check out the blog post. It's set up into 4 separate sections. So you can kind of take it one step at a time, do 1 or 2 posts and then, finish it at your own leisure. But in general, it kind of was extremely helpful to me in understanding kind of how all this stuff really ties together, because it's a bunch of different technologies and a lot of new stuff for me. But it was a good intro to all this stuff. And like you mentioned, really React is just the interface or the GUI, like he mentioned, into kind of what you're actually building on, I guess you would say, the back end or what you're actually building with Ethereum. So really, though, this could kind of be done with React Native or even Apple TV with React Native with React. So you can apply most of these principles from the blog post to really any React environment. Is that kind of also? Would you agree with that, Zubair?
I agree. I definitely agree. Yeah, that's a great point you mentioned. Yeah, it's totally possible.
So we're kind of getting close to being there on time, so I don't want to go over too much more stuff, but I really would like to talk about Solidity a little bit more, because we haven't gone too much into depth about that. Can you kind of talk about how easy or how hard it is to pick up Solidity, and would you compare it to like a language or a framework or both, or any tips about Solidity would be very helpful, I think, to a lot of the listeners.
Yeah, absolutely. So definitely read the documentation is something I would say just off the bat. It's how I learned Solidity. Reading the documentation and playing around with the remix editor is really all we need. It's very essential. Solidity, they say it looks like JavaScript, but then again, JavaScript looks like Java and C++. So it's a little. I think that feels a little ambiguous to me. So to me it feels more like JavaScript and C, because there is a struct type we can use in Solidity. So essentially, it's not too hard to pick up as a language. What is more challenging is the fact that we have to think very carefully about the cost of each line of code we write. Because remember, each line of code we write costs us gas, right? So we don't want to just carelessly write code, and then if somebody tries to execute it, costs them a lot of money, right? So one has to be conscious about this, and to know this, the documentation is really wonderful. Like, for example, the Ethereum virtual machine is a stack machine that operates on 32 bytes at a time. So it's ideally good that we work with 32 byte chunks because it's easy for the EVM to process that. So if we work, we say something's 33 bytes, that'll take up 2 stacks on the Ethereum virtual machine, and that's no good. So thinking about how much gas the code is going to consume is something that's critical for Ethereum for Solidity development. And also security is something we need to think about because this is, in the end of the day, programming money essentially. So the way I would recommend dealing with security is just to read everything that's out there. Consensus has some really good security practices. Open Zeppelin and Zeppelin Solutions have really beautiful, safe Solidity code that we can copy paste to create more complicated smart contracts that are needed for our business or our new company that we're starting. So as far as writing the code, I think it's not too hard. It's harder, in my personal opinion, to get the mindset of security and get the mindset of, oh, this code is going to cost this much gas. I think that's the uniqueness of programming with Solidity. But as far as writing it, it's pretty straightforward. The first line usually tells the Solidity compiler like what version of Solidity we're going to use. It's always a good idea to use the latest one. And it's a good idea to be specific about the version if we're going to deploy it in production, because other versions might have some security vulnerabilities that a hacker could use to hack our contract. These are just good security practices, and they're mentioned in all those places I mentioned: Consensus, Open Zeppelin, Zeppelin Solutions, these places. And to write it, it's not too bad. It actually looks pretty much like JavaScript, like they said, with a little bit of C thrown into it, if you use structs, for example. So to write it, you just write contract, the word contract, and then curly braces, close curly braces, and you have an empty contract. And then you declare variables inside this contract, and these variables are called state variables. This is probably a good time to talk about two kinds of memory that exists per each smart contract on the Ethereum blockchain. These memories are called storage and memory. And the difference between them is persistence. Storage is persistent data for the smart contract. So suppose say you create a contract and it's necessary for the code to know that you are the manager of this contract. So you can just store your address on a manager variable. You can just write address. Address is a type. Solidity is a statically typed language. Address public. Public is the visibility setter. It'll ensure that anybody, the variable is publicly available. Also, public keyword creates a getter function. So if you create address public manager and the manager is set to be the address of you can just invoke manager with open parentheses, close parentheses, and you'll get back your address. So public variable also sets up a getter. So the set of the state variables live in storage, which I mentioned is the persistent data for the smart contract. We need that because otherwise we won't be able to do much with the smart contract if all data was ephemeral. And then when a function is invoked, it gets a little bit of memory to do its job and stuff like that, and that's memory. There's lots of nuances that go between storage and memory, and the documentation is very clear on it. So again, a plug for the documentation. But that's on a high level pretty much it. So you write these state variables on the contract that you just created, and then you just write some functions. And the functions play with these state variables to do XYZ things that you need it to do. And there's inheritance built into Solidity, so you can inherit from contract. This is where Open Zeppelin is really helpful. So you can just inherit some smart contracts from them. You can import it so that it has a good way to import code that is written elsewhere. And there's bunches of libraries that people have written to do simple operations. There's definitely a gotcha here. The gotcha would be that suppose say you want to concat two strings, right? Like hello world, right? Hello plus world. This won't work in Solidity. It's not concatting strings is actually a higher level operation. Solidity is a lower level language than JavaScript, definitely, and most languages. So you'd have to engage with a strings library. There's a great library that an author published. And then you can use the concat function that library exposes to concat your string. So it can get a little bit hairy in those details. But again, not too bad. Definitely, if you're interested in developing smart contracts or becoming a Solidity developer, all it would take is playing around with it in Remix and just reading the documentation. And there's great community service out there, people helping people out. This collaborative essence of blockchain is something I really love. And I would love to see it propagate across all industries. And that would be cool if we just start collaborating together as humanity. That'd be wonderful. So yeah, going back to Solidity, would you say that's a good take? I think I'm happy to answer any more questions you might have.
No, I think that was perfect. I think that kind of boiled down a lot of the questions that I had and answered them. So that was really good.
Oh, thank you.
So before we kind of wrap it up, is there anything that anyone wants to discuss or cover that we haven't already gone over? Anything important? Okay. So I think we'll go ahead and get to the picks. So Lee, do you have any picks today?
Yeah, I would definitely want to mention Zubair's blog post again. It's really, really good. So definitely want to throw that out there. And then I've changed mine because this is such a complicated topic and new to a lot of people. There's a pretty good blog post on Hacker Noon that's really high level and introductory to blockchain. So I think that's a good thing. If you really don't know where to start before going through Zubair's blog post, and I'll post a link to it. But this Hacker Noon is just a guide to understanding blockchain and cryptocurrency. Maybe that's a good primer to get you into going through an example of actually doing it.
Cool. And I would love to throw out a very, very beautiful demonstration of Blockchain 101 by Stephen Alders. You can just Google that. It's a YouTube video. Alders usually gets me there. Alders Blockchain, Alders. And that's a great video showing the essence of what a blockchain is and what mining is. So I would definitely recommend that. And not computer science related, I would have to recommend the movie Black Panther. It's very good. It came out recently, Marvel movie, and just worth the watch. Definitely one of the better movies I've seen in a long time. So
yeah, but get your tickets online.
Yeah,
get your tickets online. They're hard to come by.
Yeah, hard to come by. Yep.
Yeah, that's funny. I just took my kids to watch Black Panther yesterday, and my son left saying it's his favorite superhero movie now. It was very well done. It was very different than a lot of the Marvel movies I'd seen. It was really well done overall.
Yeah, very thoughtful. So I very much appreciated that.
Yeah, it had like a good message.
Yes.
So my picks. My first one is a couple of books by Gary Vaynerchuk. I don't really know a lot about this guy, but just looking him up on the internet, I wasn't too impressed or thrilled by reading anything he had to write. But a couple of people that I respect a lot were telling me, hey, check out this book. One of them is Crush It, and the other one is Crushing It. I have Crush It on my list to read. I've already started reading Crushing It, and it's called Crushing It, How Great Entrepreneurs Build Their Business and Influence, and how you can too. And it has really a lot of thoughtful information about how to, I guess, deal with social media in today's terms, and how to kind of build an audience. And it kind of taught me a lot, and it reinforced a lot of assumptions that I had, and it also kind of brought a lot of new ideas that I hadn't really thought about. So if that interests you, check it out. My other pick is a project that I've been working on at AWS quite a bit lately. It's called AWS Amplify. It's basically a JavaScript library that allows you to interact with a lot of these services that AWS offers that were really complex for me to get into at first, but kind of Amplify has made them a lot easier for me to kind of learn and understand. So you can deal with S3, you can deal with analytics, you can deal with things like push notifications, and there's a bunch of different ways that you can interact with AWS services with just a few lines of code. And we're focusing very much on JavaScript and the JavaScript ecosystem. So React Native, but also Vue, Ionic, and Angular, and a few other platforms down the road. So if you're interested in adding services from AWS to your React Native application pretty easily, check out AWS Amplify. It's very actively being maintained. Feel free to submit issues and pull requests because we can definitely, we're definitely looking for new ideas and ways to improve the library. So I guess that wraps it up. Zubair, it was really, really nice to meet you. This is our first time meeting, by the way, all the listeners, but you're very well spoken. It seems like have you been on podcasts before, or are you just very this well spoken?
Oh, no, thank you. No, I haven't been on a podcast before, but I'm a poet and I write poetry and I read poetry in events. So I'm a very big fan of the English language. It's not my first language, but I definitely fell in love with it. So thank you. I really appreciate your compliment. I'm glad it shows. I like this language quite a bit.
Awesome. Very cool. Yeah, hopefully we can stay in touch and maybe connect or have you back on for some future episode maybe. So
yeah, no, that would be wonderful. Yeah, thank you so much, Nader and Lee. I really appreciate your time. It's definitely been an honor for me to be on this show.
Cool, thank you. You definitely helped clarify an extremely complex thing. So I believe a lot of people will get a lot of good understanding out of all the things you shared with us today.
Oh, that's great. I'm really glad to hear it. I'm glad it was of value. Thank you.
Well, thanks to everyone for listening, and that wraps up episode 90 of React Native Radio. We'll see everyone next week.